Hello guys, welcome back to Maison African Motives. Still on our revisions for Industrial Electronics N3. We're just going to focus on this paper, which was actually written in November 2014 on our Kirchhoff's laws. So this is a request from our students that we must work on this part as a revision. So yeah, let us just try and see. Actually, this was a nice question. It has a lot of things to consider as we are preparing for our exams that are ahead of time. So I'm not going to waste much of your time. Let us quickly rush through our question 2.1. We are given to study Fig 1, which is this part on the diagram sheet, which is this one, attached, and determine with the aid of what? Of the Kirchhoff's laws. All right, so I've got the first part here. Let us see on our diagram first. So let us try to analyze our diagram and see what is happening in this case. So if we are to check, we have got the flow of currents here. All right, let us check. We've got the supply voltage, which is 10 volts, a plus and a minus, then the current going up. All right, to this side, I've got I2. Then it means this side, it represents current 3. So this is our I3 in this case, all right? So if we are to formulate, we can see that this will give us the sum, the difference between these two from our Kirchhoff's current law. Remember, the current flowing towards the junction, meaning to say we are referring to current 1 in this case. Remember, current 1 is this one that is also here, this one. So we are saying this current 1 must be equal to the sum of these two currents flowing away from the junction. That's where we obtain this one to say I1 is going to be I2 plus I3. So it's going to be I2 plus I3 in this case. So what simply happened here is that we made I3 to be the subject because remember, we just want to maintain working with two unknown values. Instead of working with the three unknown values, we can avoid that by making I3 the subject. So that will be I1 minus I2 is equal to I3. So that is the formula that we are seeing for current 1 minus current 2 on this part. All right, so simply a change of subject that happened. We just want to make I3 to be the subject so that we write it in terms of I1 and I2 so that at least if you are solving your equations, you are dealing with the two unknown values, not three unknown values. All right, so let us see our question here. We are being asked to determine with the aid of Kirchhoff's laws. Okay, the first part is the equation for loop 1. So take note there we are given the loop to follow, which is A, B, E, D, C, B, A. Set up the equation by starting from point. Take note on how the question is given. You are not following your own order in this case. Set up the equation by starting at point A and proceed in the direction of loop 1. Proceed in the direction in this direction that you are given from A to F and so on and so on. So take note about this type of equation that you are given there. We are asked where to start and the direction to follow in this case. All right, so I'm just going to consider this. All right, so we've got 2.11, which is the equation of loop 1 in this case, which is given as A in this case. All right, this is our loop 1, which is AFE and so on. So it's going to be AF to D. That's E, sorry, there is E there, then to D, to C, to B, and back to A. And we are asked in this case to take it in the direction starting from the point A in this direction of the loop. That is the direction that we are being asked to take. All right, so let us consider this. From this part, we know that if you're dealing with a closed circuit like what we have, we are going to have the voltage, that is the voltage that we have, which is our voltage drops that we have between the current and the resistance must be equal to the sum of the voltage that you'll be given in that loop. So if you're to consider this loop that we are following this one, we do not have a voltage source. The voltage source that we have, this one, it's affecting this loop that we are given, or it can affect this loop on this side, not the external loop, this one that we have in the external here. We do not have a voltage source. So it means we are going to say our voltage source, since we do not have, it is going to be given as a 0. That is the voltage that we have as our external voltage source, or as the voltage that we have at the end. But now we need to multiply the current and resistance following the direction that we're given, so that we have the voltage drops in this case. So we are going to calculate the V drops of each part that we are given. So we are given the first part, it's A, all right, which is our point A, and following this direction. So if we follow from A to F to C to E here to D, all this path here that we are seeing here, all this path up to the point D, we have got the same current which is flowing, which is current 3, which is in this case current 1 minus current 2. This is the same current flowing throughout up to the point D. So we can say, all right, so since we want the voltage drops here, I'm just gonna separate them. So here from A to D, from A to D. All right, let's see what is happening from A to point D, since we have the same current. The current that we are having is flowing in the same direction of the loop, that the way that we've taken our loop, we are following this in the same direction. It's flowing in the same direction as the arrow that we are given here. This arrow indicates the direction of current. So it's flowing in the same direction as we are moving from A to F to E to D. We are moving in the same direction. So it is going to be a positive. So meaning to say, we are going to have a positive, just add the resistance is 10 plus 5, because all this is affected by the same current. So you're going to add 10 plus 5 times the current, which is I1 minus I2, representing what? I3. So that is going to be current 1 minus current 2, like this. So like I said, that they are following the same direction. The current flow is flowing, so there will be a positive. So it's going to be a positive. All right, then let us move to the other point. We are now at point D. All right, this is where we are. So we are at point D. So you have to move from point D to C to B back to the point A. This is the path that you're going to follow. If we check here, we've got the same current flowing because the series circuit that we see, it's the same current. But if we check the direction that we are taking according to the loop, this is the direction. But according to the current, this is the direction that we are seeing. So as we can see that these two, they are opposing each other. This one is going this way, and this one is going the other way. The anti-clockwise, this one is going clockwise. So whenever they are opposing like this, it is going to be a negative, all right? So meaning to say this one, we are going to represent it with a negative, because it's opposing each other, the direction of the loop and the direction of current, all right? But the condition is not going to change. Current times resistance. So you're going to add our resistance 5 ohms and 10 ohms, since these are in series. All right, so you're going to have 5 plus 10 times current, which is in this case, we've got I2, which is the same current flowing, but it is going to be affected with a negative because of the direction that we are taking, opposing to the direction of current. All right, so that's our equation. You can simplify. 0 is equal to 15. We add this part, is going to be 15 into I1 minus I2. All right, minus, if we add again here, we're going to have 15 I2, collect your like terms. But before that, you can just expand the brackets. 15 times I1, which is 15 I1, 15 times minus I2, that will be minus 15 I2 minus 15 I2. So you can collect your like terms. In this case, we've got I2 and I2 on this part, which is going to give us negative 30. Negative 15, negative 15 is going to give us a negative 30 in this case. So we've got negative 30 I2, which you can just write from what we have on the right-hand side, that is 15 I1 minus 30 I2 is equal to 0. So here we haven't changed anything. We just took what we had on the right hand side, we wrote it on the side, and this on the other side. So we are not changing any sign. So this is the equation that we're going to have. But for the simplification part, or for the solving part, you can even reduce this equation in a way that you want. You got 15I1 minus 30I2 is equal to 0. I can even reduce this by 15. So I can see that 15 is the highest common factor here. So I'm going to have I1 minus, if I divide here, that will be 2. I2 is equal to 0. So I can even write this equation in the same manner as this part, which is simply one and the same thing. All right. So let us see the other part. Let us consider the other loop in this case that we are given. So this part is no longer working. We are now focusing on the other part now. All right, what is it that we are given this time? Then we are given on 2.12 that we have to find the equation for the loop 2, which is given by A, D, E, F, A. Set up the equation by starting at point A and proceed in the direction of the loop proceed in the direction of loop 2. So we are supposed to proceed with this direction as per the given instruction, but having this from the point A about the loop 2. All right, let's consider what we have on loop 2 so that we can see what exactly we are supposed to do in this case. I'm just going to work at this side since we can see our diagram here properly. So that is 2.12. So we're going to focus with loop 2 in this case, which is taken. They are saying we must take note the direction, guys, in A, D, E, and so on. In actual sense, for the loop 2 that we are seeing, we're just going to take it from D and this way, or we can take it from D going to A so that we maintain the positive of the voltage. We take it from D to A to F to E and to D. But now we are asked to maintain the direction that we are given. Remember, it's given as A, D, E, F, back to A. So we are asked to start from the point A. This is our point A, which means we are moving A, D, E, and so on. So as we move from A to D like this is the direction that you're going to take. I want you to properly see what is happening here. A to D, because we are considering this loop here. This is our loop. All right. So according to the direction that we're going to take, since you're asked to start at A and maintain the direction from A to D and so on. So what is happening is that from A to D, this is the first part that we are having. Remember, the voltage is supposed to be taken, which is we have the voltage source. But now, according to this voltage, this is the positive, this is the negative. And according to the direction of current, we understand that current is going to flow from the positive terminal in this direction. All right, this is the normal way. But now, according to our loop, we are opposing everything. The current is being opposed, this one. According to the direction of the loop, this is the direction of our arrow. We are going down. But here, this is going up. So we are opposing this one. So what is going to happen is that the current is going to be taken as a negative. The same thing what is happening was here, it's a positive. So it is going to be affected by a negative. So it will be negative, positive, which is going to be a negative in this case. So the voltage here is going to be also affected. So we are going to have it as negative 10 is equal to, then we talk about the voltage drop, which is for the current that is flowing here, which is current 1, and the resistance of 10 ohms. But as you can see, we said it is opposing the direction because current 1 is going up and us, we are going down according to the direction that we are given. So it is going to be negative 10 times I1, which is current voltage, current times resistance. You can just start with the resistance. So it's going to be negative 10 I1. That is what is happening from A to D. Then if we move on from the point D, we are going to have E, F, up to point A. This time, if we check again, this is the direction from D to E and so on. And according to this branch, I3, which represents I1 minus I2, it is flowing in this direction. So these two, again, they are opposing each other. As we are going this way, but the direction of the current is going this way. So we are going to have this as a negative. So we are going to take from point D back to the point A, we are moving the same, it has got the same current from D to A. So we are going to have this as the same current that we have of I1 minus I2, which is what? I3. So that is the direction that you're going to take. But now it's going to be a negative since we are opposing the direction of the flow of current that we are given. So it's going to be negative. We add our resistors, 10 ohm and 5 ohm together, which is going to be 15 ohms, all right, times the current, which is I1 minus I2. So I1 minus I2, remember, it is representing what? I3, okay, like I said earlier on. So that is how we're supposed to take this. Then we can simplify further. That is negative 10 is equal to negative 10 I1 minus, we add here, is going to be minus 15 into I1 minus I2. All right, so that's it. We can simplify. Negative 10 is equal to negative 10 I1, expand the brackets. So we've got negative 15 times I1, then we've got negative 15 times negative I2. So it will be negative 15 I1 plus, because we've got negative there, so it will be a positive 15 I2. Then we can collect the like terms, that is in terms of our currents. We've got current 1 and current 1, which is common. So that will be negative 10, negative 15, which is negative 25 I1. All right, so negative 10, negative 15 is what? Negative 25 plus 15 I2, like that. All right, so here we can just transpose, just like the previous case that we had. We can write this to the left-hand side, which is negative 25 I1 plus 15 I2 is equal to this negative 10 that we see. We just swapped this as they are. But we can also have this to say, let us avoid having this as a negative. The first term, we always avoid to have the first term to be a negative. At this stage, guys, you are done. You actually have all the marks. But what we are saying is that we can just reduce this so that it gives us a what? Positive. So you can reduce by a negative, a negative, a negative, so that this will be a positive because we've got negative versus negative there. So it's going to be 25. I1, we've got positive, negative, which is negative 15. I2, which is equal to negative, negative, which is going to be positive 10. So this is going to be our equation, of which for the sake of you showing this equation, it's fine. But like I said, if you want, you can, after showing this part, then you can even reduce your equations. It's going to be easier for B advantage if you're now solving these equations. So you can even reduce your equation. You can divide by 5 here, which is going to be 5 I1 minus, if we divide by 5 here, we are going to have 3 I2 is equal to, if we divide by 5 here, this will be a 2. So we have reduced our equation into simpler terms. So that is what we have this case. All right, so guys, if you are to check, this one was a very, very nice question. It tells us a lot about the voltage. If you check, most of the questions, in fact, all of the questions that we worked in our previous videos, the loop that we were given, or the loops that we were given, or the loops that we were taking, as the way that we're taking, we were maintaining it to be taken from the positive in this direction. This is how the question was supposed to be given, or from the positive in this direction. This is how the loop was supposed to be given. But now they want us to work out something. But if you find time, I want you to find the same question that you see here in this opposite direction that I'm indicating right now. You can indicate this as your loop 1, which is from A to F to E to D back to A. So this voltage is going to be taken as a positive as you go up. The same with this part, if you take it in this loop, the voltage is going to be taken as a positive. So you can say this is your loop 1, this is your loop 2. So I want you to try this question, solve it, and you'll see that you're going to have the same answers, not the equations. The equations might be different, but the answers that we have at the end, they'll be the same. So that's what I'm trying to say. So I want you to try it and see, you formulate your own equation for loop 1, your own equation for loop 2, then you solve the equations, all right? Meaning to say loop 1 is going to carry. All right, let me just give you a hint about the loop 1. So loop 1 is going to be taken, we can take this 10 as a positive now. So it will be 10 is equal to, you multiply here 10 versus I1. Then you move from A to F to E to D. We add the resistance 5 plus 10, which is 15. We are maintaining the direction of the sign. So it will be positive 15 into current 1 minus current 2. You simplify this and you have it in simplest form. So this is from your loop 1. Okay, I'm just giving you a hint, guys. You go and simplify it further. From loop 2, you're going to take it this direction. And as you can see, we are maintaining the arrow. So the voltage also is going to be taken as a positive. As we are going up, we are going this direction. So those are the questions that the voltage will be a positive because you are maintaining the direction. So loop 2, which is taken from A to B to C to D to A again. So we're going to take our voltage as positive 10 volts, which is we've got a voltage drop again here, resistance that we have, and the current I1, so it's going to be 10 I1. Then we move from A to B to C to D. If we move along this, we are going to take this as a positive because we are maintaining the direction of the arrow. So this will be 10 plus 5, which is 15. So that will be 15 times current 1. All right, so I think that will be everything. Yeah, so you simplify this further in simplest form. Just like the previous part, you solve your equations, you're going to see that you're going to have the same answers as the ones that we're going to have with these ones. So this one, I want you to try it and see if you're going to have the same answers as the ones that you're going to have on 2.13, where we are being asked now to solve this, to find the magnitude of the currents I1 and I2 by making use of the equations in question 2.11, this one, and 2.12. So we solved from these two questions, we solved and we got these two equations. So we're just going to solve. So like I said, it'll be an advantage if you write your equations in simpler form. Remember, from question 2.11, this is what we got. We can just have it as our equation 1. And I wrote this in simplest form as this equation. And from this loop, which is from equation 2.12, we got our equation of the loop as 25I1 minus 15I2, which is equal to 10. And I also wrote this in simplest form as this part. So I'm just going to use these equations in a simplest form. Yes, you can use from these equations. It's fine. All right. It's not a problem at all. The solving part is in your hands. All right. So from equation 1, we saw that we have got I1 minus 2I2, which is equal to 0. From equation 2, we got 5I1 minus 3I2, which is equal to 2. So we can just play around with our equation 1. We can make I to be the subject. Then we substitute in equation 2. We can make I1 to be the subject. As you can see, it's direct here. So from equation 2, we're going to make I2 to be the subject. All right, I1, not I2, but I1. So we're going to make I1 the subject. All right, so if we are to make I1 the subject, that means we're going to transpose I2 to the other side, which is 2I2 to the other side. So that means I1 is going to be given as 2I2, which can be given now as our equation 3. So what we can simply do, remember, from where you have made the subject, we made I1 to be the subject. You don't consider that part. You substitute on the other part. So we are going to substitute I1, which is equation 3 in this case, into equation 2. All right, so that's it. We're going to substitute this into equation 2 so that we can solve for the unknown value of currents that we have. So in place of I1 here, we are going to substitute our I1, which is given as 2I2. So that is 5 times 2 times 2. So it's going to be 5 into 2 times 2I2. It's actually into 2 times I2 like this. All right, minus this part is just going to remain as it is, which is 3I2 is equal to 2. Then we can solve. So just multiply here, going to have 10I2 minus 3I2 is equal to 2. Then we can collect our like terms. 10 minus 3, that will be 7I2 is equal to 2. So you can divide by 7 both sides. That means we're going to have our current 2 as 2 over 7 amps, or we can have this as a decimal. So if we have this as a decimal, our current 2 is going to be given by something like 0.286, something like that, 0.286. All right, that's 0.286 amps. It's going to be 0.2857 and so on, which will give us 0.286. With the same concept that we have calculated our current to, we are going to have it to calculate our I1. So as we can see, once we have I2, we can substitute this in any of the given equations, and it is going to be best for you to substitute in equation 3, because as you can see from equation 3, we already have I1 there as the subject. So you can substitute there in equation 3. That means I1 is going to be given as 2I2, which is I2, we have it here, which is 0.286. Actually, I want us to take it from the one that we have. Maybe someone wants to substitute from the fraction here, which is fine. So let us save it as 2 over 2 over 7 like this for the sake of others. So if we multiply this, we are going to obtain 4 over 7 amps, all right? But if you want to have it as a decimal, you can have it, which is 0.7, 142, and so on and so on. So it's 0.571. That is going to be our current one in amps. So that is how we could have calculated our currents in this case. So like I said, if you are to solve those equations that I indicated before, you must obtain the same answers that we have. And also this loop, guys, this circuit that we see, it can be taken in many ways. So we shall be together in the next class. We shall be focusing on the question paper. I think it must be in April or 2015, similar to this one. The diagram is the same, but the loops were being taken in different directions, meaning to say it's just a different direction that you're taking, but the answers will be the same in terms of the currents that will be flowing. The answers that you're going to have will be the same. So that's why I told you to try work out with loop 1 and loop 2. If we have challenges with working with loop 1 and loop 2 to have the same answers, let me know so that we can work it together. But I formulated the equations before, so just work from those equations, solve for I1 and I2.